Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah subhanahu wa ta'ala in this situation. I am Golam Mortuja and I am your physics teacher. Today I will discuss with you chapter 8, which is reflection of light. And so, my dear student, our first creative question is that, okay? Here you can see that this is a concave mirror, and here you can see that the object is situated in front of the mirror is 10 centimeter, and here the radius of the curvature in mirror equals to 14 centimeter, okay? And our today's first question is, what is optical fiber? An optical fiber is a very thin fiber of glass used for carrying the light by total internal reflection of light. That means optical fiber is a wire, and by using this wire we can easily send signal from one place to another place. Through this optical fiber we have to send the light from one place to another place. We can also send electrical energy from one place to another place by using the optical fiber, but at first we have to convert the electrical energy or electrical signal into the light signal. Then we can easily send the light signal through the optical fiber. Nowadays the optical fiber is widely used in communication sector, in medical sector, in many more sectors, and I hope you understand what is optical fiber. So my dear student, number B question is that here, what does the plus 3D power of lens means? That means if the power of a lens is plus 3D, so what is the meaning for that? Okay, so now I will describe you what is the meaning of plus 3D. The power of lens by plus 3D means the lens is convex lens. Okay, that means if you see the power of a lens is plus 3D, then you can ensure that the lens is convex lens. And if you can see the power is minus, then you can ensure that this lens is concave lens. Okay, and it converts a group of light rays parallel to the main axis in such a way that they gather from the optical center 1/3 meter over the main axis. That means here you can see that all of these are parallel light ray, and all of this parallel light ray will be converged by this lens, and they will meet at the 0.33 meter distance from the lens. Okay, the another meaning of that, the focal length of this convex lens is 0.33 meter. Okay, so my dear student, now I will solve C number question. Here you can see that this is a concave mirror, and the radius of the curvature in the mirror is 14 centimeter. Okay, and the C number question is, determine the distance of the image. That means we have to find out at which place the image will form. Okay, so let's start to solve the math. Here you can see that the given value, the radius of the mirror r equals to 14 centimeter, and we know that the focal length f equals to r divided by 2. So 14 divided by 2 equals to 7 centimeter. Okay, and the distance of the object, that means the distance of the object, here you can see that u equals to 10 centimeter. Okay, and we have to find out the distance of the image, v equals to what? Okay, so my dear student, to find out the distance of the image, we know that 1 by u plus 1 by v equals to 1 by f. This formula. Okay. So here I want to change this from the left side to right side. Okay. Because I want to find out v. Okay. So if I change this, then the sign will be changed. Okay. And now if I put the value in this equation, that means here you can see that f equals to 7 and here the u equals to 10. So 1 by 10. If I put this value in my calculator, then I will get 3 by 70. Okay. So the value of v will be plus 23.33 centimeter, and the answer will be plus. Because here you can see that the answer will be plus means the object will form in front of the mirror. That means the image will form this side where the object is situated. Okay, that's why the answer is positive. Okay, and the image will create from the pole of the mirror to the far from 23.33 centimeter in front of this mirror. Okay, I hope you understand what is the distance of the image and how can we find this value by using this formula. My dear student, the D number question is here. If the object is kept at the 5 centimeter distance in front of the mirror, that means we have to keep the object at the 5 centimeter distance in front of the mirror, where the focal length of this mirror is 7 centimeter. That means we have to keep the object inside of the focal length. Okay, and after that we have to analyze this by drawing the shape, nature and the position of the image. Okay, so at first we have to draw the figure. That means we have to draw the image. Okay, how the image will draw in this concave mirror and what will be the shape of the image, what will be the distance of the image. Now I will describe you. Okay, so here you can see that AB is the object. Okay, AB is the object. Okay, at first the light ray occurs from the A point. That means the light ray occurs from the A point and the incident on the D point. Okay, after that the light ray refracts from the main focus through the DF path. That means after incidental ray on the D point, the reflected ray will go to the DF path. Okay, and through the main focus. Okay, that means when the light will fall from the A point on the D point, then the reflected ray DF will go to the DF path through the main focus F. The another light ray from the A occurs along the center of the curvature. That means the another light ray when they come out from the A point and the incident ray will incident on E point and after that reflects in the same path. That means the incident ray will incident at the point E and after that the reflected ray EA will be go to the same path. Okay, that means the reflected ray will follow the incident path. The two reflected rays do not come together in reality. That means here you can see that the DF reflected ray and the EC reflected ray, they do not meet each other in the reality. Then where the image will form, that is the question. Okay, they come together at A point if extends backwards. Here you can see that if I extend the reflected ray DF at the backward side, okay, and also the reflected ray EC at the backward side, they will meet at the A prime point. And I hope you understand this A prime point is the image of A. Okay, now A prime B prime perpendicular is drawn from the A over the extended part of PC. That means we have to extend this PC at the backward side, and we have to draw a perpendicular from the A prime point to the extended part of PC, and the perpendicular will cut the PC at the B prime point. And I hope you understand this B prime is the image of this B. Okay, and if we join the A prime and B prime, then this A prime B prime is the image of AB. And I hope you understand how the image will form for the concave mirror. Okay, and here you can see that, my dear student, I will discuss with you the shape of the image. Here you can see that the image is larger than the object. That means this image is magnified. And the second nature of the image, virtual and upright. You know that if the image for any mirror is created beside the mirror, then the image will be virtual. Okay, this image is upright. But why this image is upright? Here you can see that the object is look like that, and also the images look like that. But here the difference between the image and the object is the image is larger than the object, but they all look like same. They are not inverted. Okay, the image is not inverted from the real object. Here we can see that the image is upright or straight. Position of the image behind the mirror. Okay, behind the mirror the image is created, and you have to remember that if the image is created behind the mirror, I hope you understand the shape of the image, the nature of image, and the position of image. Okay, my dear student, now I will solve second creative question. Here you can see that this is a concave mirror, and here this is an object, and the distance of object from pole to object is 35 centimeter, and the length of XY object is 12 centimeter. That means the length of this XY object is 12 centimeter. Okay, now the question number says determine the length of image if the magnification is 1.5. That means we have to find out what will be the length of image if the magnification is 1.5. So here at first I have to write the given value. Here you can see that the length of object is 12 centimeter. Okay, so L1 equals to 12 centimeter. Okay, and the magnification M equals to 1.5. Okay, and the length of image L prime equals to what? That means we have to find out what will be the length of image. Okay, so if we want to find out the length of image, we know that M equals to L prime by L, where M is the magnification, L prime is the length of image, and L is the length of object. So here L prime equals to M into L. Okay, so if I put the value of magnification M equals to here 1.5 and the length of image L equals to 12 centimeter, then we will get, after the multiplication, 18. Okay, so the length of image will be 18 centimeter. Okay, now the length of image equals to 18 centimeter. I hope all of you understand how to find the length of image by using this two value. Okay, my dear student. Now the D number question is explain the nature, position and size of the image with a ray diagram. Okay, here you can see that the distance of AB object is 35 centimeter. That means the distance between pole and the object is 35 centimeter, and the center C equals to the double of focal length, that means 15 into 2, 30 centimeter. Here the object is situated far from the center, and I have to draw the image formation in this concave mirror. Here you can see that AB is the real object, and when at first from the bottom side of the object, that means from the B point, the light is traveling towards the center of the mirror, and when the incident ray will incident on P point, and after that the reflected ray will go to its previous state. That means the path of incident ray and the path of reflected ray will be same. That means the incident ray BP and the reflected ray PB will be same but the opposite direction. And after that I have to draw the another two ray which will come from the A point if we want to know the exact position and the exact size of the image. Okay, so for the first thing, when the light is traveling from A point and parallel with the main axis, and when the incident ray will incident on M point, after that the reflected ray will passes through the MF path. Here you can see that MF is the reflected ray. Okay, and for the second ray, when the light is traveling from the A points and towards the center, and the incident ray will incident on M prime point, and after that the reflected ray will passes through the M prime A path. Okay, that means for this time the path of incident ray and the path of reflected ray will same. Okay, that means here you can see that MF and the M prime A reflected ray will meet at the A prime point. Okay, that means A prime is the real image of A point. That means A prime is the real image of A. And here, as the ray incident along the principal axis refers back along the same path of AM, that means the image of B will be formed on that line. That means the image of B will be formed at the main axis. Okay, and here let us draw a normal B prime A prime at the point of A prime. That means I have to draw a normal from the A prime point to the main axis, and the normal will be A prime B prime. Okay, so B prime A prime is the real image of the object BA. Okay, that means B prime A prime is the real image of AB. So I have already drawn the image of this object, dear student. Now I will discuss with you the nature, position and the size of this image. Okay, here you can see that the image is real image. Okay, because at the which side the object is situated, at that side the image is created. That's why the image is real image. But the image is inverted, because here you can see that the look like of image and the object is opposite from each other. Okay, that's why you can say that the image is inverted image. The position of image is between the principal focus and the center of the curvature. Then here you can see that C is the center of the mirror and F is the focal of this mirror, and the image is created between the center of the mirror and the focal of the mirror. Okay, moreover the image has decreased in size. That means here you can see that the size of image is smaller than the object. That means the magnification is less than 1. I hope you understand how the image will form if the object is situated far from the center of a concave mirror, and what will be the position, what will be the size, and what will be the nature for the image in a concave mirror. Dear student, I hope you have enjoyed the class and you have learned the things which I have already discussed with you. Inshallah, see you on the next class. Assalamu alaikum, my dear student.